Welcome back to part 2 of the Cisco ThousandEyes for CloudDevs series. This is a guided workshop series on service monitoring using the Cisco ThousandEyes technology. And what you saw in part 1 was an overview of what the ThousandEyes technology is about and how it will apply to you as a cloud developer. We also walked through how to procure it through AWS Marketplace and how to deploy the ThousandEyes software enterprise agents using AWS CloudFormation to get new EC2 instances of ThousandEyes deployed in any AWS region that you're interested in. This series, part 2, is about configuring the agents now using the ThousandEyes portal, and then how to interpret the results and how to configure alerts. What will happen next in part 3 is some best practice recommendations and some advanced topics like web transaction monitoring. And I'm really excited to go through that because we're going to use an example of an e-commerce site and how to monitor the various interactions that your customer might have with your website. But let's go ahead and move on to part 2. First, again, provisioning ThousandEyes tests. The first consideration that we have is what are we going to monitor whenever we think about availability, latency, packet loss, or user experience monitoring. We need to think about where the users are. And those users can be developers, they can be our customers. And in a cloud native sense, the user or developer might be at home and the code is either being developed or executed in an IaaS type environment like AWS. And the code could also be offered or hosted in some kind of SaaS environment like GitHub or Docker Hub. We may have situations where our work is kind of a teleworker model where some of that code exists in that user's home and that it is synchronized out into a SaaS or IaaS type environment. Or it may be even a hybrid approach where the information is sent to a private or a hybrid data center kind of experience. So once we understand where our developers are, where our users and interested parties are, then that can help inform us where to place agents and monitoring tests that we're interested in. Now, what you saw in part 1 is I used an example of Graciano, or Grace for short, as an app dev who lives in Portugal, and she remotely accessed her company's development environment, which was in AWS region US West 1. And she fits a cloud native model because she doesn't have this code being developed in her home. She is a remote accessing and getting to it in AWS, and she's also using SaaS services like GitHub and Jira across the internet. So as we think about Grace and what her situation is, the first thing we want to monitor is source A going to target B. So her home going to a cloud environment. So that's client to cloud. The next thing we would think about would be source B going to target C, or going from cloud to cloud, these inter-region or inter-availability zone type traffic and workloads that she might have a development environment in one region and a database or an authentication service, a load balancer in another region. And we need to comprehend all of those as we're going through and looking at the service that we're offering. And then finally, her example might be going from source B out to target D, and that would be cloud going to SaaS offer like GitHub or Jira. And we talked in part 1 about agents, but we'll do a real quick refresher here. The cloud agents are ones that Cisco deploys, and there's over 400 of those across different service provider network locations. You don't have to configure them or maintain them, do software image maintenance on them. Cisco handles all that. They're available for you to use in your ThousandEyes measurements and testing. And again, because they're placed in specific location and they're shared resources, you have access to them, but they may not be exactly placed where you want. So then you might supplement your testing with enterprise agents, and these are ones that you deploy yourself. And these can be little virtual machines, Linux virtual machines. They can be AWS EC2 instances like we deployed in part 1. You can even put them on a Raspberry Pi or an Intel NUC and run them as an embedded software agent on those single board computers, and then place them wherever you want, closer to your workloads, important VIP users, etc. And then endpoint agents are essentially browser plugins that you can put on select developer environments, and this will monitor specific websites that you tell it to monitor. This is not a wholesale, all-access, overly permissive collector. If you say to monitor this user's access getting to GitHub or Docker Hub, then it will measure those and nothing else. The next thing we have to do is think about what tests we're going to provision, and this is where we get to pick our poison. Now, I'm going to suggest that the application to CloudDevs are going to be the green check marks. So there may be some more advanced ThousandEyes test capabilities that you would want your infrastructure SMEs to be working with, like the routing and BGP tests. But you, as an application developer, probably interested in how your access is going and how customers access your app, would be interested in the network agent to server, agent to agent, and then the DNS tests. I also believe you'll be highly interested in the web HTTP server test, because that will mimic and provide the ability to look like an API request or testing the connection to a database socket. Page load and transaction are also very interesting if you're doing e-commerce type sites and you want to gauge the user experience of those sites. If you're hosting a file, then file transfer, FTP, might be something you would be interested in, but I'd mark that lower priority. If your application is in the collaborative space or voice or video streaming content, then SIP and RTP stream might be something interesting to you. These tests, however, are all layered, right? So as you pick a test, you might notice that there are other tests that get combined with them. It's a combo package. So you don't need to be overly permissive on recreating tests. Just check to see if a test is layered and you get the benefit of the lower layers accumulated in that test. So a transaction test against a web page is going to include page load, web server, network test, and BGP monitoring. Now, it's important to note that you can turn some of these off, like BGP monitoring we'll talk about later. You can turn off if you don't want to have that, if it clutters up the interface to you or you don't have an interest in that level of availability testing. I've put check marks here again to say that these are going to be the tests that are CloudDev aligned. So again, the HTTP server or web test being something that could mimic an API test would be one that you might be highly interested in, and it would include a network test and a BGP test. So let's get started in looking at these tests. Now, right off the bat, we have the option to click on our test settings, and then if we add a new test, we'll see that the routing layer is available along with network, DNS, web, and voice. By selecting routing, the BGP test is automatically available, which we can label and give a description. Now this one again is probably going to be a more advanced test that you may not do as a cloud developer. For somebody that is doing this, could be one of your SRE teams or infrastructure support personnel, they would put in the prefix and netmask of a network route that they're interested in monitoring for, and that the public BGP routers that would be advertising this would be monitored. If we wanted to set up alerts, then that's an option too. However, we're probably more interested in the next layer, which is network, and this would be agent to server. So that agent can be a cloud agent, or it can be one of the enterprise agents that we configured and deployed. Right? Again, we could give the test a name and an optional description, and then we need to set a target host name or IP address. Now, what is it we're trying to test with a network agent to server? Is this something like we just want to do a ping test for availability? Then we would choose a protocol of ICMP. If, however, we wanted to test out the connectivity of a port listener, like for a database, an authentication server, a credit card payment processing system, then we would put in the protocol and port that we're interested in connecting to. And then we would define an interval, or how often we want this test to run. We would then also select our agent, whether that again was a cloud agent that Cisco is hosting or one that you hosted yourself as an enterprise agent. When we click on that select agent requester, this new pop-up window appears, and we have the option to search and filter and to highlight entries based on their built-in labels. So we can see here that enterprise agents and cloud agents are organized by geographical region, and they're labeled. There are built-in labels and custom labels. So the built-in labels of cloud are the Cisco supported ones. The enterprise labels are the ones that you deploy. They're IPv4 and IPv6 compatible labels, and then the custom labels are ones that you define. So I've got DevNet and personal ones here because I have some professional monitoring going on and some personal monitoring going on. If we select a label in the window, then it will filter the list to show only those selected. So when I select enterprise, it shows the 4 enterprise agents that I have deployed. One of those being an AWS EC2 instance. That's the CDA DTE-1. There's an Ubuntu ThousandEyes agent that I've deployed in my home, and then 2 other agents that I've deployed in other places at work. I can also use the search bar and go ahead and say, look for any agents that match a city name. So I put in Orlando here, and I see there's an IPv4 and an IPv6 agent that are cloud agents that Cisco has deployed. If we're interested to poke in on that IPv6 a little bit more, selecting that label shows all of the agents across all the different regions, and within the US we have 38 different IPv6 cloud agents that Cisco has deployed. Now, when you're doing that network agent-to-agent test, you have to select source to target, what those agents are, whether they're cloud agents or the enterprise agents that you've deployed, and then what direction you want them to test in. If we move on to the DNS test, then we've got 3 test types: DNS server, DNS trace, and DNS sec, or DNS security. Now, I think the first one, DNS server, is probably more appropriate to a cloud developer because this allows us to test the name resolution of a domain that we've registered, and you don't want to lose your domains, right? Sometimes those registrations expire and then somebody else jumps in and takes over your domain. So you should always monitor the expiration of your domain, but also the resolution of it to make sure that it's resolving quickly enough. DNS trace would be a more advanced capability to look at how it's resolved through the authoritative servers and the routes all the way down to your corporate authoritative DNS servers. And this again is a little bit more advanced along with the DNS sec or DNS security. And these 2 may be ones that your SRE or infra teams are very interested in. However, if we move into the web layer, this one is something I think a cloud developer is interested in, and specifically the HTTP server test type, because this one allows us to gauge the availability, latency, packet loss measurements against something like connecting to a service, a socket, maybe even an API. And in that regard, what we do is we define the URL and path to that service. We define the interval, how often we want to run the test. Then we also define what agents are going to run that test to the target or URL that we just defined, and if we want to do any alerts. Now, that's all you really need at the basic configuration level, but you can move up to the Advanced tab or the Advanced Settings tab and then define how long should it wait in a timeout sense before it throws an error. What is the target response time in case we want to set a threshold that things are getting too laggy in response. And then if we want to disable some of those options like the collect BGP data, I said before we could turn that feature off if it was polluting our interface a little bit too much and we didn't care to look at the hop-by-hop path analysis tools. Or maybe that type of measurement is something that only your SRE team is interested in. So you could disable those depending on your preference. And as we scroll down, if we have proxies that we have to deal with, then you can define those. You can define if there's a TLS or SSL version that you're specifically interested in connecting to. Verifying the certificate is also very important from a production network standpoint. I know a lot of people set up self-signed certificates and then they have their browser set to ignore them. But this is a case where you can have a ThousandEyes agent monitor whether that certificate is valid or not. And then if there's any authentication that needs to be done, what type of HTTP version, whether it's the traditional HTTP version 1.1 or the newer HTTP 2 quick type version connections, and whether it's a get or post type operation. You may want to define a user agent. You can say, I want something that looks like a Mac user running Safari or an iPad user, and then define any custom headers if there are any necessary for your API to be connected to. As we continue to scroll down, you can define whether the success of this is a default 200 or 300 status code, or you can choose to ignore that. Moving on to page load, this gives us a little bit more interesting information because now we're gauging how that Apache web server is doing, or Flask, or whatever is hosting up our page. And we know that there is DNS lookup time, there is network time in flight, and then there's the web page serving time, and that has some aspects of how efficient the web server is or how complex our page is. And we can define the URL to that, again, how often to do the measurement and what agents we want to use. If we're interested in web transactions, like if we're running an e-commerce site, then we can use this web transaction test type, which allows us to download a recorder, which is essentially a Chromium web browser with some enhanced API capabilities that monitor the clicks and all of the graphical elements as part of a web page. And in that, we can do specifically the same activities we would expect a user to. Clicking on an e-commerce site, searching for something, logging in. We can also look at something like a shopping cart and take a snapshot of what's in the shopping cart to make sure that everything reconciles the way we expect it to. This is a really cool test that we're going to go through in part 3 of this series. Now, if you don't use the recording system, then you can create your own transaction scripts, but it's a little bit interesting to do that. So I would suggest that you go ahead and use the recording script, because it will go ahead and generate this transaction script for you, and then you can manipulate it later if you want to by adding screen snapshot buttons, conditions, and other logic. Now, you may have a situation where you are hosting a file of some kind. Could be an Excel spreadsheet, a document, or some other file. So you can also use ThousandEyes to test downloading those files from a hosted location, whether it's using raw FTP or one of the more secure methods. Finally, as a more advanced method, if you're doing something that's voice or video, or content streaming related, you can use this voice SIP server or RTP stream capability to simulate those phone calls, collaboration sessions, or streaming sessions, and define all the different tracing and protocol methods that you would use to simulate that. And again, this is a more advanced type of test. Coming up in the next section, we're going to go through interpreting these test results. Moving on now to interpreting the test results. When you access your ThousandEyes portal and select the dashboards option on the navigation panel, what you're going to see is a screen that looks something like this. And it's pretty generic to start with, but it may have had some modifications. Somebody could have laid out different panels for you. So just be aware of that. This is something that can be customized, and widgets can be added. But with the default, what you see is an alert grid, and I have no active alerts right now. An enterprise agent status panel, which is showing the 3 agents that I have deployed, and that's a mix of enterprise agents that I did on a Raspberry Pi, a Linux Ubuntu agent, and also an AWS deployed agent that we actually covered in our part 1. The other side of that, the endpoint agent status, is reflecting the browser plugin status for the agent that is embedded onto my browser. And if we scroll down, what we'll see are all the tests that we have, what their location or endpoint that they're monitoring, if it's a website, the test type, what the alert status is if we have alerts enabled. In this case, I've got 3 that have no alerts. And then on the right hand side, we see essentially some trending sparkle graphs showing availability and latency type measurements. And you can click on a specific test if you're interested in more specifics there. So this DevNet by AWS TEEA, or ThousandEyes Enterprise Agent, is one that I created, and it's running in AWS, targeting the developer.cisco.com website. So I'm monitoring DevNet's website. And again, it's a page load type test, and it's green right now from alert standpoint. When I select it, we'll see that it has a summary of all agents that are pointing to it. So right now I'm looking at the view for page load and the metric of page load time. And we're seeing a pretty good result here. In the details in the map section at the bottom, we can see the DOM load time of about a second and the overall page load time of 2.7 seconds. And we have several agents across the world map that are targeting the developer.cisco.com website. I can change over and look at the upper right hand corner and see there's an opportunity to save this report, but I can also share it. And the share feature is kind of fun, because if I'm interested in pushing this information out to a partner to troubleshoot, or send it to my internet service provider to explain why there was an outage, then I can hit that share button, and I can either do a snapshot share or I can export the data. A snapshot share essentially creates a dynamic URL, and it emails that to whoever you ask to email it to, and you can put in an optional text message with that. So I can say, for this time and about 4 hours around that instance, send a snapshot to this email address. And what they'll do is they'll get this dynamic email with a URL and a shared link. Now, when they click that email link, they'll essentially get a simplified read-only view of your ThousandEyes data. They can expand and zoom in to different aspects of the metrics and time frame, but they can't change anything about your collection and your tests. They can only see the results of it. So this is good, again, when you need to share with another team for troubleshooting perspective. Now, if we're not interested in a summary of all of the agents, we can click on the agent drop-down selector, and we can select a specific agent that we want to focus in on. We can also change the metric from page load time, or even change the view, in this case moving from page load over to HTTP server, and now we're looking at how that Apache server is doing in hosting that web page. And the metric may be something that we can change from availability to response time and throughput. When I look at the screen, I also notice that I have 10 agents that are monitoring that website, and 4 of them are throwing DNS errors. If I want to, I can check what those are by clicking down a bit and looking at the errors and warning. And what I see here is that these 4 errors are coming from IPv6 specific web agents that Cisco is hosting. So what I can intuit out of that is the web page does not have IPv6 capability. There's no quad A DNS record, and so there's no way for it to resolve developer.cisco.com in an IPv6 only network access. So we're showing it to you here, warts and all, except for this one over here. And moving on, if we want to look at the network overview for loss, latency, and jitter, we can select that view along with the metric to see if there are any of our agents that are showing loss. We can also see the latency, and if they're creeping up or getting really bad, we can see that. And we're looking for spikes, right? And trends that are going the opposite direction from what we'd like. Jitter, if you have a application that is voice or video related, then it's time sensitive. And jitter is the variance of delay between the source and destination as the network traffic gets queued up inside of a device and dequeued as the buffers are unspooled, essentially. So jitter is bad for voice, video, and streaming type applications that are sensitive, and we want to make sure that that's not going on. And overall, this looks pretty good. The jitter is staying less than 5 milliseconds, which is excellent, and it's pretty consistent from the overall experience here. Now, path visualization and the next one, BGP route visualization, these are more advanced topics that your SRE teams might be interested in. And as they click on that, they'll see the hop by hop path as it goes through each router between the source and the destination. Now, if they want something a little bit more generic, then they can go to the BGP one, but in this path visualization, we can also select each hop and see, who the service provider is that owns that, and a little bit more public information about that hop. Even the cloud agents have a little bit more detailed information, so you can look at those to find out what their public IPv4 addresses are and what the responsiveness of those agents are. And finally, for the BGP route visualization, if we're looking at that view, then what we're going to get is essentially a service provider handoff perspective as the traffic goes from service provider to service provider. And sometimes service providers make mistakes. They configure something that accidentally black holes traffic or sends it some direction it's not supposed to go in. And we see this as a useful report for those situations to find out why did I lose all my traffic coming out of a certain country or a certain service provider. And in that regard, we can focus in on a specific service provider representation to say, show us this device of this service provider, what was its interface, the reverse DNS name, and also were there any path changes through this, because routing is dynamic, right? Now, as we have all of our tests running, if we're interested in the reports, we select that from the navigation panel and we get a summary. 100% uptime for my reports that are running, for my tests that are running, and I have no alerts currently. Now, if there were some, I would see in the middle alerts over time, and I have had some where one of my service providers decided to take down a website for some maintenance for a while, and it was an extended maintenance period, and I was able to show them the stats using ThousandEyes of when my website went down and days later when they brought it back up. If we scroll down on this reports, then the alert table will appear, and we can see from a region perspective if our collections and tests have access to different assets that are in different regions. Then we'll see like my tests right here are mostly North America bound, and I don't have any alerts that are showing up in each of those tests. Coming up in the next section, we're going to discuss how to provision the alerts. All right, moving on to provisioning alerts. And what you're going to see here on the navigation panel, if you expand alerts, is that there's an alert list. And if there's anything active, they'll show up here. And I don't have any, but I can look in my alert history and I can see that I had a couple times that my personal website was down, and I can navigate in to look at that rule. And my rules are essentially, if the web server has an error, then throw me a notification here. I can add new alerts, and this is something that you probably want to do. And you'll define the alert type, the layer, and the test type. So for a web type test, you're going to have HTTP server, page load, and transaction options. Give it a meaningful name to you, and then define the tests that match that alert type. You don't need to do all of them. You can be selective. Sometimes you may run tests that you don't care to have alerts to. And then you would define the agents if you want to zero down even more. The alert conditions are something that's pretty useful, because you may find that you get alerts, but you don't want them if it's just a one-time issue, a little blip on the network, right? So you can define conditions. You can have multiple conditions. You can say how often or how many times in a row this condition has to occur before you get an alert. So if it's something that's a blip, you might ignore it. If it happens more than 2 of 3 times or more than 5 of 7, you could do that, whatever suits your purposes. And then as you get down into your alert conditions, you can see that error is a prominent one, but there are some other more advanced ones, like if you wanted to check the SSL version to see if a banking e-commerce site changed their security level or something strange, or the cipher suite. But you're probably more interested in things like throughput and response time to know what your user's experience is when you create your alerts. Finally, it would be no good to have alerts if you couldn't disable them temporarily if you needed to suppress them because of some known maintenance. Now, if you do know that you're working on something in a data center or taking a service offline, you can go ahead and use the alert suppression feature to say from this time to that time, go ahead and disable alert monitoring here, and you won't be made aware of anything during that known time interval. Coming up in part 3, something I'm really excited about: best practice recommendations and advanced topics, especially the web transaction monitoring. Look forward to talking to you again there.